So today I would like to make a proof of concept for an astrology web application using WebAssembly to leverage the power of the swiss-ephemeris library. So first things first, let's check out the swiss-ephemeris library. So from our search engine on astro.com, we have our documentation and our source code. Now, from our documentation, we find our planetary positions with these functions, but we already have a warning telling us that we should set an ephemeris files path from our file system to make the calculations more precise. Now, because with WebAssembly and running in the browser, we do not have access to the file system, we should set up an in-memory file system so our WebAssembly can have access to these files. And this can be quite a hassle, so we could use either mscripten or WASI to help us out. And because mscripten might be too much, let's just try with WASI. So let's just download our source code first. And let's say Astro and curl this guy out. And let's just open wasi.dev and see what we have in here. And also we shall need our WASI SDK to build our files. And yeah, let's extract this out. So with tar and remove this. So in here we have our source files, and on our make file we can see that we can build our executable, or rather our WebAssembly, by using these object files. So let's try and do a simple build.bash script. So from our shebang, and let's do our chmod and make this a executable. And let's see what we got on our SDK. So we have a very convenient Docker image, which should have everything we need to build for WebAssembly. So let's run this out, and let's do bash to see what is going on in here with remove IT. And because we are mounting this directory and building inside here, we should set up some user permissions. So let's look for docker volume user permissions, so that we do not have to sudo everything every time. So there should be -u somewhere in here, and there we go. This should be it. Let's just hope this works. Oh, I just lost it. Okay. Bash. Let's do gu, and if we copy from here, yeah, there it is. Now, from inside this Docker container, I believe this worked. Yeah. Okay, so let's do print-env, and in here we have clang ++ and clang 16. Okay, and our C flags. So let's do cc and c flags, and let's build our object files in here. So let's substitute .o by .c, and this should be with the G flag. Okay. Yeah, I think this should work. So if we do build.bash, it did not work because we need some dynamic linking stuff in here. So on swef.c, So let's see, so f.c on line 251. Yeah, we just comment this out and see what happens. Now we have more errors because on 268. So what is going on here? Get library path. Yeah, let's just comment this out. Let's say to do and fix this. Maybe is this being used? I don't know. I just want to compile it, and there we go. There it is, our object files. Now let's try and link them together. So on build.bash, if we do -o, and let's say astro.wasm, we should maybe think of a better name here, but this is fine for now. With these object files, okay. And let's, for sanity, remove everything beforehand. But these C flags might not be everything that we need, I believe. So astro, let's do, I just closed everything by accident. It's fine. So these C flags, we also need, because this is just a library, we need no entry, and also we should maybe export everything and do no start files, I believe, because there is no main function or anything. And yeah, this should be enough. So if we do docker bash, now let's do build.bash and see what happens. Oh, it worked. Wasm. Yeah, there we go. And this is quite big, right? Probably because everything is being exported. But let's try and run this in the browser. So let's do, let's say Astro web app, I don't know. And we should get our polyfills from the WASI example. So yeah, we have to use npm here, just so we do not just simple copy everything out. And in here we can have our file system, which should be very convenient later to load our ephemeris files. But first, let's just try and run this. Actually, because we are maybe running this thing, we should use webpack, or let's try with vit. Getting started, how do we do this? So create vit, Astro web app. I do not want a framework, and TypeScript. Okay. Okay, let's move everything here and remove this guy. And what next? There's no node modules just yet, so npm install, and let's also install this guy. And what do we have on index.html? So I do not want this, and this is fine, and this is Astro Web to do, and we have our script. Okay, div app. What is going on here? On source. This is useless, so goodbye. And we do not want this. And what is this? Yeah, goodbye. Okay, and on main.ts. No, 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 no. Yeah, let's just copy this out and see what happens. What is going on here? So we do not want to worry about this just yet. And var is full and no arguments. Yeah, let's just clean this up. So this should be string array, and this should be astro.wasm. And because this is synchronous, let's do a sync function main and move this everything in here, and then main catch. Let's do console error, and TypeScript is complaining about this type, right? Yeah, okay. Let's just say this is unknown as any. Okay. Actually, let's just log our instance first. Yeah, and this should be fine. Now, because we are running from public, let's remove this SVG and move our astro.wasm into the public folder, which is this guy. So yeah, I think this should work. What do we have here? So this is npm run dev on localhost 5173. Localhost 5173. So I believe, yeah, this is working. So we have our source files here and our WASI file, or WASM file. Now, sock accept. Why? This is too much, right? We do not need all of this. We do not need a socket API. So this is actually exporting, maybe, yeah, this is exporting everything from the swiss-ephemeris, and that's why there is so many dependencies from the standard library. So let's just not export everything. So this should be dynamic, and let's see what happens. And now this is only 12 kilobytes. Let's try and move this in here and refresh. Now this is much better. Yeah, we have very little in terms of dependencies, but we are exporting only our memory. So what I want to do now is export some stuff from our library. So on our documentation, we want calqt. So let's just grep for this on C files. And there we go. So swef.c, swef.c, we have calqt. So yeah, there we go. So in order to make this public again, let's do visibility. Default, this is an attribute. Yeah, there it is. This is what we want. And because this function requires a Julian date in universal time, we also need some date functions. So let's search for date. And yeah, this should be it. So UTC to Julian date. Now, where is this guy? So date.c. Okay, so date.c. And yeah, there we go. So let's just copy this string in here, and I think we are set. Okay, so let's do docker build bash, and right, yeah, there you go. And now we move this guy again and reload our web application. And now, yeah, there we go. Now we have access to these functions, finally. So let's just do, so we should have memory and calqt and UTC to JD is our instance.exports. And let's do a noun as any, so we can just fix this later. Now, our signature for this guy should be this. So let's see what we have in here. So what is going on here? Yeah. So let's do UTC to JD, and we need year and month and day and hour, min, seconds, and a greg flag, which should be 1, and an array of 2 doubles and a string error. So this should be direct and s-er. And let's do now is new date, and year is full year, and month and day and hour. Thank you, Copilot. And our seconds is actually a double, so this is correct. Yeah. And our greg flag should be 1 because we are using the Gregorian calendar, so greg flag. And our direct is a float 64 array. But we should use our exported memory. So memory.buffer 0, 2, correct. And our error string should be uint 8 array, correct. Now this is 16 because this is 2 times 8, right? Because we have 2 doubles here. So yeah, this should be fine. So if our code is less than 0, just let's log this out. Yeah, beautiful. And the Julian day that we are interested in is direct on index 1. So this is index 1. And let's just log this guy. So this is declared but not used. Oh, come on. Just, yeah, okay. And let's see if this works. It did not work. Cannot read properties of undefined. Reading exports. So what is this? What? Inst exports. Yeah, this is our start thing, which we deleted. So let's do. I think this WASI start and our instance. Okay. As unknown as any. Come on. Okay. So the start method wants both an instance with exports memory and exports start. But we do not have a start function just yet. So let's just set this up by doing just create this guy here. So start with a single underscore and just return. Yeah, it should be fine. So docker run and build everything. And we should move our astro.wasm in here and refresh. And it worked. Okay. Okay. If we do Julian day now, what is it? Can I have a number? Yeah. Okay. You come here. So this is looking great. All right. All right. We are making progress. Now let's try and do call qt. And what do we have in here? So this should be with this signature. And let's do call qt. And we already have our Julian date in universal time. So you come in here, and our IPL is just I believe our body number. So yeah, it should be 0 for sun, and Copilot is ahead of us. Okay, so 0 is sun, and then we have iflag. So let's see, iflag. So 0 should be the default. Yeah, so let's try this first, and later we can try something else. Now, our code is this. let's do IPL, I flag, and what else do we need here? And then an array of 6 doubles for our speeds and positions, and a error string. So let's do XX is exactly a float 64 array with 6 fields or positions, and a SR which already exists here. So let's just do reset this. And this is 6 times 8 as our offset. And I think we're good. So if you are smaller than 0, what is going on? Decode this guy. Why is Vim so weird right now? Wait, what? What? Let's just do calc code is calc code with error. Yeah, okay. Vim is being weird right now. It's fine. Okay. So let's just return and let's do const lon and let, and we do not care for this, so this is speed in long, so long speed is on index 3 and let speed is in here. So let's console table these guys and see what we get. So back in our browser, and there we go. There we go. We have some results in here. No speeds though. This should be an issue with the flags that we passed. We passed 0, right? Yeah, we can fix this later, also by using our ephemeris files. But let's search for astrology planets position now and see if our calculation is, if our results are okay. Now this in here. So one of the reasons I'm building this is because it's very hard to get easy informations from the web for astrology values. But from astro.com, we actually have something very useful here for our use case right now. So yeah, I think this is fine because this should be the sun is on Leo, so we have Aries and then Taurus and Gemini and Cancer and then Leo. So this is 1, 4, so 4 times 30 plus 14 plus 20 minutes divided by 60 plus 56 seconds, so divided by 60. And there we go, 134,348. Yeah, this is looking really promising. Now let's try with the moon, because the moon is so this should be 0, 1. Where is our planets? moon, it should be, yeah, there you go. Moon is 1, so this is moon, and now we have 27.5. Yeah, this is looking great. So Aries 27, and this is about half of a degree, and there it is. Beautiful. Let's try one more. So 2 should be Mercury. So this is Mercury, and we have 161.5. So this is Virgo. So this should be 5 times 30 plus 11 plus this divided by 60 plus some minutes, some seconds, and what? Yeah, plus 161.52. Yeah. Okay. Okay. I think we're good. So let's just do next steps. We should load our ephemeris files and see if it actually works. And we also need maybe we already have the positions of the planets, so maybe we can do some calculations. So we have aspects and transits and etc. And because I do not understand anything about this, let's just find some users, astrologers, to test this with and actually see which features they want. And for that we need draw some charts with canvas. Yeah. And I don't know, maybe we can build something interesting here, which I don't know if we can publish this, because I have not looked into the into our licensing, but maybe for my own use this can be fine. And before publishing anything we should take care of this. So verify the license conditions of swiss-ephemeris. Okay, thank you very much.